So in the last video, we learned how the sodium-potassium pump created the membrane potential of the neuron. Notice here in stage 1, the outside of the cell has a positive charge. That positive charge is created by the heavy concentration of positive sodium ions outside of the cell. The inside of the cell has a high concentration of potassium ions, which are also positive. However, because 3 sodium ions were pumped out of the cell and only 2 potassium ions were pumped into the cell, the overall charge of that membrane is negative. If we look at the graph at the very bottom of the slide, the resting potential is negative, around negative 60 millivolts. That negative membrane potential is created by the uneven distribution of ions on either side of the membrane. At this resting state, the sodium channels are closed and the potassium channels are closed. In stage 2, depolarization, stimuli start to come in through the dendrites. Some dendrites might receive stimulatory signals when other dendrites receive inhibitory signals. Notice that there must reach a threshold before an action potential is fired down the axon. This depolarization occurs when inhibitory signals are less than the excitatory signals gathered by the dendrites. As some sodium channels open, sodium ions rush into the cell and start to depolarize or change the membrane charge of the neuron. Once the threshold is reached, the action potential will fire. Firing of an action potential is an all or nothing event. So once the threshold is reached, all the sodium channels will open and sodium will rush into the cell and depolarize the cell. Notice now that the inside of the cell is positive due to the rush of sodium ions into the neuron, and the outside of the cell is negative. The membrane has completely depolarized. When that membrane has depolarized, that action potential is spread down the axon until it reaches the axon terminal and the neurotransmitter is released. In stage 4, the membrane needs to repolarize, so we see the fall of the action potential. The membrane potential, which is now positive, needs to reset. We need to bring it back down to the resting potential. During this fall of the action potential, notice that the sodium channels are blocked. The potassium channels, on the other hand, now open, and potassium rushes out of the cell. This repolarizes the cell, so the membrane potential becomes negative once again. In stage 5, there is a slight undershoot where the membrane potential goes below the resting potential. That occurs due to the excessive amount of potassium ions leaving the cell. That undershoot will allow the sodium channels to be no longer blocked, and they are ready now to receive a new message from the dendrites and open up once again.